Hello, this is John from caveofprogramming.com. In this video, we're going to start taking a look at coroutines in Kotlin. Coroutines are a way of writing asynchronous, non-blocking code in Kotlin. So they're kind of an alternative to dealing explicitly with threads and thread pools and that sort of thing. A thread is a separate process that kind of runs by itself, and you can have multiple threads at the same time. So you can have multiple strands of code running at the same time effectively, and this is what we mean by multi-threading. And this is kind of a simple way to achieve that in a way that means you actually don't even always need to explicitly use multiple threads, although we can do that with coroutines if we want to. Before I get into this, I want to just revise a little bit of syntax here. Let's say we've got a function test like this, and let's have another function down here which I'll call runner. Now we've seen before that if your function just returns an expression, you can simply use an equals sign and then the expression that you want, which could be something really simple like this. It could even just be a simple value, although there's usually not much point in doing that. Suppose we want test to be the same as function runner. We could actually then implement test just by saying test equals runner round brackets, and then we've got two functions that do the same thing essentially. If we have a print line in here that says maybe hello, and then we run test up here, we're going to see hello because test is the same as runner. Let's just run it, and you can see it says hello down there. Now let's make runner accept some kind of function. So we can say that it accepts a parameter which is itself a function, and let's say that that function accepts no parameters and returns unit. So now when we do this, we have to actually pass the function that runner should accept to runner in order for this to work. And to do that, we could use a lambda expression. So I could put curly brackets here. There's a function that accepts no parameters and returns unit. And we could put some code in there like print line hi. And in fact, we could make runner run it if we want to by just doing action round brackets to actually call the function. Now, you probably will recall if you've been through these videos that if a function is the last parameter to another function, you're actually allowed to miss off the round brackets here. This is the trailing parameters feature of Kotlin. So now we've got something that looks like this. It looks kind of weird. But what's actually going on here? Let's first just run it, and we can see that we do actually get hi coming out down there. So we've got a function test, and that's basically equivalent to the runner function, with runner being passed a lambda expression, so it's being passed another function, and the function that we're passing to runner before making test equivalent to that actually just prints hi and returns the default unit. So this all looks a bit complicated, and if you feel confused by it, I think it's worth spending a little bit of time typing this out and experimenting with it before you go any further, because we're going to see some syntax that looks exactly like this in connection with coroutines. But let's delete this for the moment since we don't need it. Actually, I'll just leave it though, it's not doing any harm. So now the next thing that we need to do is bring in the coroutines library, and how you do that depends on how you build your project. If I go to File, New Project, if you're using IDEA at least, you've got a choice between using the built-in IntelliJ builder or Maven or Gradle, which are sort of cross-platform builders. And if you use Maven or Gradle, in either case you're going to have a config file which you can edit. And if you want to bring in a dependency, you want to automatically download some jars and include them in your project, you can go to mvnrepository.com and search for your dependency in there. In this case, I'm searching for Kotlin X-coroutines-core. And if we click on the first one that comes up here from org.jetbrains.kotlinx, so we'll go to that and click on a version. So I'll use the latest version, which at the moment is 1.10.2. And then in there you can see the code that you would have to type into your Maven or Gradle config files in order to bring that dependency in. But I'm actually not going to use this in this video, and part of the reason for that is I tried these and couldn't get them to work, and that was just because I'm using OpenJDK. I think for some reason Maven and Gradle didn't seem happy with that. I've actually forgotten precisely what went wrong here, but in the end I found it easier for my purposes here, rather than switch to a different JDK and figure out the problems. I'm just going to use the built-in IntelliJ builder for this. And if I do that, let's just cancel this because I don't actually want a new project. I can go to File, Project Structure, Libraries. At the top here there's a plus sign for adding a new library to your project. I'm going to click that. I'm going to click From Maven, and I'm going to type Kotlin x-coroutines-core and click the search button there. Of course you need to be connected to the internet, and I'm going to select one of these from org.jetbrains.kotlinx. I'll select the latest version, which as we've seen is 1.10.2 at the moment. So I select that and I click OK, click OK again, and then click OK. And you'll probably get a message down here saying the following files are downloaded, and it's downloaded the Coroutines library that I actually need here. Now what we can do is I can set main equal to a function called run blocking, and this is a coroutines builder, and it accepts a single parameter which is itself a function. So I'm going to supply that with a lambda expression by putting curly brackets here. So you can see that this is exactly like this. Then I'm going to hover over it and go to import function run blocking, and as long as you've got the library incorporated already into your project, that should work fine. This creates what we call a coroutines scope. It's a scope where we can add coroutines, and the run blocking function, which we've set main to be equivalent to, will actually block the main thread until all your coroutines, all your separate bits of asynchronous code, have finished running, which is useful because it is a common problem with multi-threading, although easily resolved, that if you spawn off some threads, your main function can finish before the contents of those different threads have finished, and then the threads just get terminated and don't get a chance to do anything. So it's quite handy that this actually blocks the main thread, or at least prevents it from exiting, I should say, until all the coroutines we're going to specify have finished. For the moment, let's just put a print line in there, and I'm just going to say hello, and we can see that if we just run this, it's just going to run as if I'd got a normal main function in here. Now I'm interested in what different threads are being spawned here, and as we're going to see, although what we're going to achieve looks like it's using multiple threads, in fact everything here in this tutorial is going to just run on the main thread. Here I'm going to write start1, and we're going to display the name of the thread that's running. So by default, when you create a Kotlin program, you're going to have one main thread, and all your code by default will just execute on that single main thread. And what we are going to do in this particular video is not going to change that, as you'll see, even though it looks like it is doing. So I'm going to put curly brackets in here, and we'll have thread.currentThread, that's a function call, .name. And then let's duplicate that and have end1. So we'll see the name when this thread is ending as well. And in between we could have, for example, print line hello. And if we run this, it does what you'd expect really. So you can see that the name of the thread that this is running on is just main. It is the main thread, the default thread that just starts up when you create a normal Kotlin program. Then we print hello, and then we've got end1 down here. Now what we can do is add some asynchronous code into this. We can add something that will run at the same time as this. So let's add in a launch block here. This is another coroutines builder. I'm going to hover over it and go to import. And in there, let's do something very similar. So I'm going to copy all of that. I'm going to copy this as well. And we'll put something in here like hello from 1. Actually, I don't want 1 here. Let's call this 2. I'll put start2 and end2. And let's run this and see what happens. So if I run it, what happens is a bit interesting. We've got start1 on the main thread, and then it says hello, and then we've already got end1 all in the main thread. And only after that does this stuff actually launch. and it says start to, still running in the main thread, and hello from to, and then end to. So this line actually runs as the last thing in the program. So this is kind of already a hint that something interesting's going on here, but you can see that no new threads were spawned, so the program did just work through all my lines of code, even though it did it in a little bit of a strange order. Well, let's have another launch block here. I'm going to just duplicate this and we'll have start 3, hello from 3, end 3. So now we've got two of these launch blocks, and let's just see what happens when we run this. Okay, so now we've got start 1 main, hello, and end 1 main. Start 2 main, hello from 2, end 2 main. And so they're just running in order. Then we've got start 3 main, hello from 3, end 3 main. But what you can do with a coroutine is you can effectively suspend it. So I'm going to use a function in here called delay. Where should I put it? Maybe I'll put it here actually. Let's put it right here and put in delay. And this takes the number of milliseconds that we're going to delay for. So let's try maybe 2000 milliseconds. And this is a long parameter type, so I'll just put an L there, and we'll hover over delay and go to import function delay. Not sure that worked. Let's try that again. Oh yeah, I've got to actually select this Kotlin X coroutines delay. Okay, there we go. Now it's working. So what delay does is, unlike sleeping, so there is a sleep function that can actually block a thread. Delay doesn't block a thread. Delay will suspend the work that's being done in this coroutine, and it will allow the thread that this is running on to attend to other work while that delay is happening. So let's take a look at what happens when I run it. Maybe I can make this a bit bigger. There we go. Let's try this. So now we've got start 1 main, hello, and end 1 main. So we had that before. The whole of what I put in that run blocking scope at the top level is just running. Then we've got start 2 main, but then we get into the delay. So the actual main thread, which all of this code is still using, is then suspended from using the code in this first launch block. But that doesn't block the thread, because what happens is the thread then attends to the work in this second launch block. So we see start 3, hello from 3, and end 3, and that all successfully runs in that 2-second delay that I've created. And then finally, after 2 seconds, we're going to get the resumption of that code in the first launch block up here, and we see hello from 2 and end 2. So if we run this and pay close attention to it, you can actually see that there is a delay of 2 seconds before this actually runs. So let's take a look, and you can see most of the program's already just run, but then finally after 2 seconds we get the hello from 2 and end 2. So what we've achieved here is we've managed to get these two launch blocks really running as though they were on different threads in a way. They're running asynchronously. So it's not that we have to work through all of this and then, and only then, we can work through all of this. It's that we can actually suspend this and allow the main thread, meanwhile, to attend to something else, like another launch block, and that can then run in this delay. So that's it for this video. This is a long video and there's a lot of stuff in here to digest, but I'd recommend just typing this out, trying it out for yourself, experimenting with it a little bit, and you'll soon get the idea. Nothing very complicated is really happening here. It's just that we've created some code running on the main thread in such a way that it can be suspended, thus allowing other code also running on the main thread to run at the same time, which is kind of interesting as a starting point. And we'll look in more detail at this in future videos. So until next time, happy coding.